Alright, so in this question we have a large shipment of light bulbs and we want to do a quality control. Alright, so our claim is to determine whether the mean life is equals to 7,478. Alright, so for this purpose we are using the sigma. The population standard deviation here is 100. So this is our sigma is known, which is 100. Now the X bar, we collected the sample. We collected the sample of 64 and we find out that the sample mean life is 7,453. So this will be X bar, 7,453. Okay. The level of significance alpha is going to be 0.05. Alright, we start with our hypothesis testing. So the mean here that we are trying to figure out is our claim. Alright, so the claim, if you remember right here, so the mean is, it means equal sign 7,478, and the alternative one would be the opposite statement, which is the mean is different than 7,478, and the claim would be the top one because that's what is written on the text. All right, okay, so how can we proceed with this? First of all, we're going to use the p-value method, and the reason because on B they are asking us for the p-value, so it makes sense to use the p-value method. So on the graph, what we're gonna have is we are having the alpha. Obviously, this is a two-tail. All right, so we're gonna have half of the alpha here, alpha over 2, and the other half is gonna be right here, and alpha over 2. So this is gonna be alpha over 2, which is 0.05 divided by 2, and that should be equals to 0.0250, and the same thing here. This should be alpha over 2, and which is equal to 0.0250. Now, where the alpha at is the threshold between accept and reject. So here it can be do not reject zone, and the outside is going to be reject. Okay. All right, so how can I get the p-value? So first of all, I need to calculate the z stat, and the formula for z statistics is equals to X bar minus the mean divided by sigma divided by radical n, and if you plug it in all the values, so the X bar we have 7,453 minus the mean, which is 7,478, and divide by sigma, which is 100, divided by radical 64. All right, so time to plug it into the calculator. All right, so this is gonna start with a parentheses, 7,453 minus 7,478, and then divide everything by open a parenthesis, 100 divided by square root second squares here, and 64. Then x is the square root, close the parentheses, and enter. So I get the value -2. So then once I get the z value -2, I can determine the p-value from the z table. And remember, this is -2.00, and that is only half of the p-value, right? Because it's two tails, right? So going to the table, trying to read -2. So -2, it would be -2.0. So this is -2 here, -2.0 there. So it can be 228. Okay, so the value we just read is half of the p-value. So the p-value will be 2 times 0.0228. And we end up with the p-value equals to 0.6 here, 5. Okay. So now we have two values, the p-value, and we have the p-value and the alpha value, right? So we can compare them together. And the rule to use here, if the p-value is smaller, so p-value less than the alpha value, the conclusion here, if it is true, reject 80. So let's verify whether it's correct or not. And the p-value, we are having 0.0456. The alpha value is 0.05. So you cannot compare them, just put 4 digit. So this is 456, this is 500. So this is a false statement. That's not true. Actually, it's correct. So this is a correct statement. The p-value is smaller. So your conclusion will be reject 80. All right. And we can explain it in the graph as well. So here, if I draw only half of the p-value, this is 250, and half of the p-value will be 228. So it can be a smaller area. It will be here. This is p-value divided by 2, which is 0.0228. All right, so we notice here this is the threshold and is falling within the rejection zone. So we're gonna reject the null hypothesis. So if you reject the null hypothesis, we accept H1. All right, so we have enough evidence. So there is enough evidence to reject 80. All right. Now, are we supporting the claim or not? We do not support the claim. Remember, 80 is the claim. We do not support the claim. So what the meaning of we do not support the claim? So 80 is that the mean life is 7,478 hours. However, according to our sample, we figure out that is actually not the case. It could be less, it could be more. That's another test, but obviously here is with a z value -2, it means less. All right. So the quality control failed here, and we can do not accept the shipment. All right, so let's try to plug in the answers and see what is right. Here is 7,478 and here 7,478 again. Check it. Good. Now the z statistic we calculated and we figure out is -2. So -2 here. You can put -2.00. Right. And then what is the critical value? Okay, we did not do the critical value according to this. All right, so let's try to do it. We use the p-value. So critical value, how can you get it? So let me explain it on the chart. The critical value is, all right, so the critical value is where the alpha over 2 ends. So this part here, z critical. And because we have two tails, so this is again another z critical. And those values that you are looking for, right? Now, the value that we get according to the p-value, this is the value where the blue ends, right? And this is gonna be the z stat. And this is -2, we know it already. So now, how can I get the value over this one? Do you remember the alpha over 2, the red area? This red area here is equals to 0.0250, right? So what we need to do is go to the table and we are supposed to look for 250 as a value. And 250 is right here. So if I read it is minus 1.9 and on top is 6. So it is 1.96. Going back, so the z critical, we have two z criticals. One of them is minus 1.96 that we just found. And the other one is the symmetrical to it, which is 1.96. And why we are taking both of them? Because we have two tails scenario. All right, and how we know two tail scenario? Every time you are using H0 equals and H1 different, there is no inequality, right? That's how we know. All right, so this is gonna be two of them plus or minus 1.96 and check. Now the conclusion, we said we're gonna reject H0. All right, and do we have enough evidence? Yes, we do have enough evidence. So we are not failing to reject. We are either reject H0 here, B or D. B saying there is not enough sufficient evidence, and that would be wrong. And D, there is sufficient evidence, and that's what we are looking for. So that's going to be the answer. Reject insufficient evidence. Okay. Now they are asking about the p-value, and the p-value is explained here how we got it. So that's 0.0456. And let's check it. Great. And then according we know we're gonna reject, and we know there is sufficient evidence. So again, same conclusion, reject A0, there is sufficient evidence. The conclusion doesn't change. And then the confidence interval. All right, let's try to do the confidence interval right now. All right, so this is the formula for the confidence interval. And once you have the formula, you just have to plug in the values. So let me put some of them. Here is the sigma. So sigma is going to be 100. The n it can be 64. The Z alpha over 2, this is when we use the table and we say Z critical. That is Z critical 1.96, right? So we're going to take only the positive value for it. So we don't count positive and negative, but here the formula is counted one positive, one negative. So 1.96, and the X bar will be the value that we are given by the exercise, which is this value here out of the 64 sample, 7453. And I think we have all the information that we need. All right, so you just have to plug them in. All right, so this is going to be 7,500, sorry, 7,453 minus 1.96 multiplied by 100 divided by radical 64. And the mean, it will be between that value and the other value will be 7,453 plus 1.96 times 100 divided by radical 64. Okay, so I'm gonna just plug it into the calculator. So 7,453 minus 1.96 times, open a parenthesis, 100 divided by square root second root 64 here, exit this and close the parenthesis. So this is going to be 7428.5, 7428.5. And for the second part, what you need to do is just, you can go to same expression, enter, and then go inside and look for that minus sign and turn it into plus. So let's turn it to plus like that. You don't have to type everything, so it can be 7477.5. All right, so the verification worked out. And here the last part is you want to compare the result between A and C, and that's basically the cutoff. All right, so where the mean is going to be in between. All right, so we can do the opposite work. If the mean is in between this interval, then we accept A0, otherwise we reject it. And because the mean was 7,478, so do you notice here is slightly outside here. All right, so this is not within the 95 confidence interval. So what we say, we have enough evidence to reject the null hypothesis as well, right? So here again, the result A and C are the same, so they must be the same. So it should be A or B, and so there is sufficient evidence. This should be the right choice. And that's all.